Greetings again. Hello, everybody, and welcome to lesson 2. Okay, welcome to lesson 2. I hope you. So we're going to continue from lesson 1 here. Okay. Thank you again for tuning in. So we're going to take over from lesson 1, and so in lesson 1, I said that there are 2 types of forces. Okay, there are contact forces and non-contact forces. Okay, so I said that, and then I defined. We also defined what they are. Okay, but then I will just define again here so that just for clarity. Okay, so I want to expand on those 2 types of forces. Okay, so in this lesson, I want us to expand on what? On contact forces. Okay, so I want us to get deeper into contact forces. Okay, and the type of forces that the type of contact forces here that we're going to look at is friction, tension, compression, and normal forces. And normal forces. So the 4 types of, so I'm going to use these 4 types, okay, to explain contact forces, okay, in our lesson here, okay. So let's just revise the definition now. So what are contact forces? Okay, contact forces are forces between objects which are touching each other. Which are touching each other. Okay. So, okay. So let's get into the first one, okay? Let us talk about friction. So let's get into friction. So what is friction? Okay. So, okay, that means, so friction is the force which opposes which opposes the motion it opposes the motion of a moving object. So meaning it's on a rough surface, okay? It's not on a smooth. So if the surface is smooth, it means there is no friction, okay? So frictional forces always act in the opposite direction. In the opposite direction to the motion of the object. So it opposes because it opposes the motion of an object. So it always acts in the opposite direction here. Okay. It acts in the opposite direction to the motion of the object. So you can say the motion, or you can say the movement. So the synonym here, motion, you can also say movement, okay, of the object. So friction resists. So friction resists movement when the object when the object and surface are in contact. Okay. So the diagram here, okay, let me draw a diagram here to illustrate what I mean. So suppose you have an object of mass m. So an object here has a mass, okay, and the object is resting on a surface, okay. The object is resting, let's say, is on the floor, okay. So if the object, maybe the object, this is the floor, and the object is resting on the floor, okay. And then suppose that there is a force acting to the right here, okay. So you can say this is Fa, or we can say applied force. So we can say applied force here. And then, so if the applied force is to the right, it means the friction, okay? The frictional force between the object and the floor, okay? So somewhere here will be to the left, okay? So here you have FF, which is frictional force. This is applied force, and this is frictional force. Okay, so it opposes the motion. Okay, so it resists the movement when the object and the surface are in contact. So if the applied force is to the right, the frictional force will go to the left. Okay, so that's it there. And then the next thing is tension. We also have tension. And then we have tension. Okay. So what is tension? Okay, so we have to understand what tension is. So tension is the force that forms when a rope or a string is used to pull an object to create movement. To create movement, or to suspend an object. So the tension can be used to create movement. It can also be used to suspend an object. Okay. So now, okay, let me use a diagram here to illustrate. Say, suppose you have a block. So let's say the block has a mass and a mass m, and the object is again resting on the floor. And then, so there is a person here. So there's a person who is pulling. So the tension will form Ft. The tension force, okay, will form inside the rope here. Okay, so they say there's a so there's an image here that illustrates the tension force. So here we say what? the person pulling the rope the person pull is the person is pulling the rope, which is pulling the block. She's pulling the block. So here we say what? The person is not touching the block. The person is not touching the block directly. So there's no direct contact between the person and the block, okay? So here what? The rope is so the rope is tied, and so there is tension in the rope. There's tension in the rope. Tension is a contact force. Tension is a contact force. The tension in the rope, the tension in the rope pulls the block across the floor. Across the floor. Okay. So it is a contact force because the rope is in contact with the block here. Okay. So the tension force, Ft, the tension force formed in the rope, or the string that is attached between the block and the person pulling the rope. Okay. So let us go to compression. Let us move to compression. Okay. Now, compression is different from tension. It's not the same. So a compression force, a compression force, a compression force a compression force is a force which acts to deform or squash an object. So let us use, so okay, this time let me write it down, okay? The following diagram summarizes the difference between tension and compression. Between tension and compression. So let me show you by means of a diagram here. So say you have an object, okay? You have an object. So this is an object here. And if we apply a compression force, what would happen? The object will become a little bit more like this. So there are two forces acting in both directions, from both directions. So, and then if we apply tension to the same object, okay? So tension stretches the object while compression squashes the object. So the object is stretched. So here we applied tension to the object. It means that the object becomes stretched. And then here we applied compression. So if we say, so the compression will squash the object and then the tension will stretch the object, okay? So the object becomes longer in this case. Yeah? So the observation here, what is the observation that we see here? Is that both the forces are in contact with the object. However, compression forces are acting towards the objects, while tension forces are acting away from the objects. So both forces are in contact with the object. Okay? Then compression forces are acting towards, and then tension forces are acting away from the object. Okay, the object. Okay, let's say the object here. Okay, so that is a key difference. Okay, that is a key difference between those two. Okay. Okay. So I think that's enough for lesson 2. Okay. So we discussed up to compression force. Okay. So in lesson 3, I will talk about normal force. So normal force is, I talked about friction, tension, and compression in this lesson. Then on the next lesson, I will show you normal forces. Okay. Because normal forces are interesting, and because they depend on the surface that the object is on. Okay. They are relative to the surface here, normal forces. So goodbye for now. And I hope you tune in, and hope you tune in for the next lesson, which is lesson 3. And leave your questions in the comments and let us keep the engagement going. Thank you for tuning in. Okay. Bye bye for now, and I hope you tune in for lesson 3.